Hi guys, welcome back to the channel. Today we'll be diving into Bash Error Handling Part 2, Mastering Trap for Safer Scripts. This series we will try to explore the fundamental error handling mechanisms used in set-e, set-u, set-o, pipe fail. Um, we will try to take it further by trying to understand more about trap and its powerful features in Bash for handling signals and unexpected script failures. So what is trap? The trap command is a Bash script command which basically allows us to catch and handle signals or specific shell conditions. It enhances the script reliability and enables cleanup, debugging assistance as well as controlled exits. Why is this crucial for us? Well, let's say if we have a script which is used for creating temporary files but it crashes before cleaning them up, it can lead to the process of having to deal with resource leak. So we basically ensure that we have a failsafe. So here trap would allow us to ensure even in such kind of a scenario a cleanup action can be performed. In production, trap basically allows us to prevent unexpected behaviors which makes the script safer. So basic agenda is we get a basic understanding about signals, the trap fundamentals. We will try to implement trap and a cleanup operation, try to handle exit codes, as well as maybe demonstrate some real world use cases. The first section we will try to understand what signals and the trap commands are. Signals are basically notifications which are sent to a process by the kernel or any other processes, which basically indicates whether a specific event has undergone termination, interruption, or has stopped because of certain resource constraints. Some of these signals, if you might already be aware, it's called SIGINT, which is a signal for interruption. This is sent whenever you press Ctrl plus C. Then there is something called as SIGTERM. SIGTERM basically means terminate, which is used to terminate processes. SIG up basically means hang up. Here the signal is sent in a way that the terminal stops the session. SIGKILL is short for signal kill, which forcefully terminates a process. And we have SIGQUIT, which is used for quitting, but it basically allows us to have some data left over for analysis. We can basically enable trap commands to allow us to forcefully terminate specific processes, which would immediately initiate any cleanup operation at the final step if some of these steps were skipped. Let's just try to get to a basic usage of trap. Let's say we basically create a capture.sh command, and we will try to catch a sig interrupt signal and prevent any abrupt termination. So we will make a function to handle this interruption, and we will set up a trap for the sig interruption. And once we press Ctrl C, the test trap handling or this is initiated, and we will basically try to handle this. Let's just try that. So we will create vi, let's say capture. I think I already have a capture.sh, so for the purposes of this I will say capture signal.sh. Okay, let's just go to capture signal. .sh, go into insert mode. First thing that we will do is set up a function to execute when the signal interrupt is received. So that's what we will do. So we will write handle something like this, handle interrupt just say we basically set up a script like this. We'll write echo -e. We will just print out the message script interrupted. Let's say cleaning up before exit, some message like this. We basically then exit with the exit code 1. Now we will set up our trap, so we'll just write a small comment, trap for the signal interrupt, which is Ctrl+C. So yeah, let's just trap it with our function. So we'll write sig and int. This is a shorthand form of basically saying that we would like to initiate the script once we receive Ctrl+C command from the user. So here we will then write the message running the script. Let's just say Ctrl+C to initiate test trap, some message like this. We will set up while true. We'll set up a condition. We will go to sleep. I will basically write the script running. Yeah, and then we will write something like this. So yeah, let's just say we try to enter. So what happens here is that we have basically defined handle interrupt, which is a function to handle SIGINT or signal interrupt. The trap command basically is set up such that when the function is executed, when the interrupt is received, so we would enter an infinite loop, allowing us to test this Ctrl+C. So yeah, let's just try to execute this. We will write bash capture signal.sh, and once we hit enter, we basically are now running this script, and we are just basically waiting for the user, that is us, to basically press Ctrl+C. Once we press Ctrl+C, we basically have exited. And why did we just exit? Because we just gave the signal that we would like to exit. So once that signal interrupt was held, we basically caught it in our handle interrupt function, and we just exited. So that's what we did right there. So another way to implement this is to implement it with cleanup. So here we would like to get rid of temporary files whenever the script is terminated unexpectedly. So for the purposes of this, I guess we can store our data into some file. So here we have ls, we have a folder called tmp. So here we will store our data in a temp file.txt. We will basically set up a cleanup function which will delete the temporary file when it is executed. We will set up a trap command called trap cleanup signal interrupt. We will basically handle signal interrupt and signal terminations as well as exit, and once that is received, we will manually perform these tasks by basically forcefully terminating or exiting the script. Once that happens, we would basically terminate the all the files. So let's just try to build this. We will just clear our workspace, let's just say, and we will write some script like vi, let's say script with trap. We just see the current files okay, I have a bunch of files. Let's just say trap signal interrupt, okay, something like this. Go into vi. Okay, so let's just try to implement this function. So we will just let's just say temporary file location. We will define that as tmp file, and we will just pass our file path to this temporary file location.txt. So yeah, we will now define function to clean up temporary file. So we'll define cleanup, and we will basically set up, we'll say a message echo -e. We'll basically capture all the errors and basically say line command cleaning up the temporary files. Then we will write rm-f. This will forcefully remove any of the files which are located within this particular location that we have specified, and then we will just exit with our exit code 0. So yeah, here we need to initiate this trap command first with some of these interruption signals. So it could be trap signals which could terminate the script. So we will just simulate that. We will try trap, it could be cleanup, it could be sig interrupt, SIGINT, SIGTERM, and exit. Let's simulate the trap file creation process. Let's just say echo create a temporary file. So we will just write our location, and this will basically go ahead and put out this specific information to the user that in this specific location that we have mentioned already as a prerequisite, this file will be created, and thus, and here we basically do the process of creating this temp file. So yeah, let's just try to process it. Just say okay, so echo message it out like processing. We'll write press Ctrl plus C to test cleanup. So yeah, this would try to simulate some level of I guess work which is happening. So we'll write simulating a task, something like this, and then we will write final exit message like process is successfully complete, something like this. So yeah, and then we exit, and now we will try to run this. We will write trap signal int.sh. As you can see, what we have done here is that this file is basically in a loop. It will continue to show us this message for 10 minutes, and once that is done, it will basically clean up the files. So even though the script was interrupted, trap basically ensures that the temporary files were removed. So let's just try to see if the files exist. So you can see that the file, we will just try that again. I'll just say yeah, something like this, Control C. So yeah, even when we try to exit, the file will not exist at this particular location. As you can see, the tmp folder file was basically created and was removed. So yeah, that's one way of handling errors. Another way to handle exit codes with some real world application is to handle different exit status. So in this next script, we will try to implement a trap handle error which would trigger another function whenever the command fails. Let's say the user basically provides a non-existent directory. The script will basically exist with the error message. So we are basically trying to enforce a structured error handling instead of some silent failure. So let's just uh, try to do that. Let's just say switch failed vi check .sh. Okay, we already have a file like this. We can modify this for the purpose of the same. Just remove the contents. Let's just say we have a directory which we basically take as an argument from the user. Set up $1. So yeah, now we will basically set up a function to handle the error. So let's handle error. With a function like this. So we'll just write echo -e new line command, error has occurred, exiting, and then we will exit with the exit code 1. Let's set up a trap to handle this said error. We'll write trap handle error. So what we have done here is that if any error is found, we basically handle this by invoking this specific function with the help of the trap command. So let's just say if the user checking for the directory, let's say if -d something like, we will basically check if this specific directory exists. If it is, condition is not true. In this case, we are basically checking this if this particular directory is not present. We basically write directory is not present, and we will basically display the location which the user has passed. And yeah, we will basically exit with exit code 1, and we will close the save statement. And yeah, if this is not the case, we'll basically say yes, the directory exists, something like this. And yeah, we will just write and quit. So yeah, let's basically run this command. Okay, sorry, I have to change this. So yeah, so here if we just pass some non-existent directory, let's say non-exist, something like this, non-exist directory, here let me just see something I have missed. 16. Always remember to set up space between your conditions, otherwise you will get random errors like this. So let's just do that again. So yeah, this works perfectly, because the last time it was just saying that this directory that we haven't created exists. So let's just try to write something else. Let's say demo, which we have created. So you can see that we basically have handled this specific process. The next steps that we can try to do is advanced trap use cases and debugging techniques. Since we now understand the basics of trap, let's explore some more advanced scenarios. This would include debugging scripts, handling multiple signals, and let's just try to work out with some logging errors as well. For that, we basically use something called as debug. So what is debug? Well, debug uh, is a kind of a debugging in bash scripting, which allows us to print variables or step through commands manually. The trap would capture every command executed within the script, and we will basically do that with the help of the debug signal. So in a way, this allows us to log and analyze the script execution in real time. So let's just clear our workspace. So yeah, we will basically demo trap debugging with the function called debugging. Let's say this would execute before the command runs, and yeah, let's just try to implement a basic structure. Let's just say bi debugging sh to insert mode. Let's just say bin slash bash. So yeah, let us set up a function. So function to log each command before execution, something like this. Say debugging function, we'll write echo, and we will print out the message debug executing, and we will pass the bash command here in this particular variable. So yeah, let us set up our trap. This trap will capture every command, so we will try trap debugging. We will basically invoke this specific function and then write debug. Okay, and let's just go ahead and say echo. Let's just try to create a new let's say temporary file. So yeah, here we will write touch. We will create this temporary file within tmp and write debug file.txt, and here the next command that we'll go ahead with is step 2. We will list the files in temp. We will write ls -temp, and we basically will try to get hold of any particular data which is there matching this text. And then we will go ahead with the third step, right, like something like this. Like we will remove the file. Let's say remove the file. We'll write rm tmp / debug file.txt. And yeah, so the final script would be message would be like debugging complete. So yeah, let's just go and see what we let's go into a little bit of the depth. So what here is this, that this particular bit, the trap debugging debug, executes the debugging function whenever a command is executed or before the command is executed. The commands, okay, I have to also make it small change. So yeah, this part the spelling is wrong, I have to fix it. This bash command would hold the command which is about to be executed, and each of the steps are printed, and therefore we get a brief understanding of what is happening and what is aiding the debugging process. So let's just go ahead and fix this file. Go up again. So yeah, something like this. So yeah, as you can see, our command is excellent at debugging or troubleshooting certain scripts. We basically keep a track of the let's say track of the execution flow, and any of the logical errors or unexpected behavior are caught. So you can see that let's say when we are trying to create the particular file, here the debug command would basically show us the command and basically print out the message before each and every one of these scripts or commands are going to be executed. So this is what debug basically allows us to do. So yeah, let's just clear the workspace. The next command, we will try to handle multiple signals. So we will try to handle multiple signals simultaneously and ensure a robust script execution. So let's try to create a script that can handle SIGINT, SIG termination, SIG hangup. So yeah, for that we will basically write a function called handle exit, which would ensure cleanup before the script exits. The trap would basically invoke the handle exit whenever we get signal interruption, termination, or hangups for these signals. And yeah, the script would basically create a temporary file or enter an infinite loop. So let's just try to run this. Let's just go and write this script in VI. Let's just say multi signal trap set into insert mode. So yeah, let's just say function to handle different termination. We will say handle underscore exit, and we will basically capture setup a statement echo -e, which would say like we received. Let's say we received the termination signal and initiated cleanup. When we will remove all the files from this temporary let's say script file that we have created, and we will basically exit with exit code 0. So yeah, we will now, let's say, trap multiple signals by initiating this specific script. Let's just say handle exit, and we will say SIGINT, SIGTERM, or SIG up hang up. Okay, let's just okay. So yeah, now let's try to create this text file. So we will go ahead and write slash, let's say, multi and we will write the message file has been created, process is running, try terminate with kill command. So yeah, this is an infinite loop, and let's just message that infinite loop. So yeah, while, let's say, while the condition here is just randomly doing condition true, and we will just exit. So yeah, as we just mentioned, we will try to handle multiple of these signal interrupts with the function handle exit, and yeah, this script would create a temporary signal temp file in the tmp folder while this runs infinitely. So yeah, the idea is that we will open the terminal we'll get the process ID for this particular script, and once we pass a signal interrupt, we will basically see that this particular message has been received, and this process would initiate the cleanup task of doing the removal of this particular text file, and then we will exit this particular signal. Yeah, but we can always press Ctrl C as well. So yeah, this is one of the multiple ways to handle signals at production to prevent unexpected failures. We can use kill as well. So yeah, let's just go and try that. So we'll go bash multiple signal sh. So we have basically initiated the creation of the file, and let's just go ahead and let's give it Ctrl C. As you can see, we'll just try to see if this particular file exists. No, because that particular file just got deleted. So here the process is happening in the background. So let's just try that again. If I let's say go ahead and do this again, let's open another terminal and open another terminal here, so we can just get a better idea of what we just did. We'll try to get hold of the process ID related to this. Okay, let's just go ahead and write ls. Okay, let's just try that again. Yes, aux multi-signal trap set. So as you can see, our process ID is is 23481. So yeah, we will try to kill this. Let's just say kill -15. Our PID is 23481, and enter. Let me just try that again. Let's just go back to our other. Yeah, so you can see that we just terminated our script, and we basically have initiated the cleanup process as well. So yeah, that's one way of handling. Let's just close this. Let's say multiple signals at as well as handling unexpected failures. So let's just go ahead and try to implement a trap command for logging errors in a script. Logging is a part of automated scripts. Let's say we can basically use the trap command to log errors whenever they occur. So let's just try to log these messages into a error log text, and we will basically set up a log error function, and whenever the errors occur, we basically append the error details whenever the command fails. So we basically would write trap, the function name, and the error signal which has been received whenever the command fails. So let's we will try to run it with some ls commands, try to look up for some directory that doesn't exist, and then we will log that specific error detail into this particular script. So yeah, let's just try to set that up. We'll write something like log error .sh, going to insert mode /bash. Let's just set up our log file location, so something like error log.txt. So yeah, let's just write func to handle errors. So yeah, let's set up log underscore error function. So this function will basically let's say we will log in the date time details, so something like echo, let's go ahead, something like this. The date command would basically display the dates, and we will basically write error in script. This is the message that we want to uh, log it in, so we will write let's say the command, and we will mention with single quotes the command that failed, so bash underscore command. So we'll write something like fail to exit. Let's just try that, something like, okay, let's just put it as two parts. So this command has failed, and we'll write echo and mention the failed exit code, which is $? So this will basically display the error code, and we will basically mention that we are logging it into our log file. So yeah, so this is how this would set up, and we will basically now write the trap command. So trap something trap followed by the function log underscore error, and we will basically try to capture the error, and let's just simulate some commands here. So we'll write echo executing some commands, and we'll mention, let's just try leave it some non-existent directory. This is an error, so this will definitely cause an error, so let's just say script successful. But yeah, we can also try something else. We can also try it with the existing tmp folder, and yeah, so what it does is that the log file that we have set up over here would store these log errors, and this function would append the errors whenever the command will fail. In this case, we know that this command that we are trying to execute will definitely show an error. This will cause this command to be, this specific command to be captured here, and the date time and the error code and all that information would, this part exactly would get logged into this particular let's say this code, into this text file. And yeah, and this is basically initiated by our trap. So in this case scenario, when we run the script, we are basically deliberately causing the error. This basically causes the error to get logged into the text file, and later on we can basically check the whether this process has happened or not. So we will try to, let's say, ls something different, let's say another non-existent file, something like this. So yeah, in this case we know that this would be successful, this part will cause failure, so will have two logged failures within the temporary script file. So we will write bash log error.sh. So yeah, our log file basically went ahead and showcased that these directories do not exist. We basically logged the data into that particular text file, and we basically go ahead and show all the other details along with it. We basically try to execute another non-existent command. So in this case the second command was successful, that's why we basically see some extra details. And yeah, so yeah, I hope you learned something today, and I will see you in the next one. Bye.